All right, so I need a document camera. All discombobulated. So your only homework for Monday is to get the review done, which I told you about yesterday, pages 35 to 46. So please make sure that's all done for Monday, so that way we can spend a class period reviewing and getting ready for Tuesday's test. Once we finish today's quiz, we're going to do a lab on circuits. Again, a good review. All right, so here are the answers to these multiple choice questions you were assigned. Number 1 is 4. Number 2 is 1. Number 3 is 2. Number 4 is 3. Number 5 is 3. Number 6 is 3. Number 7 is 4. Number 8 is 1. 9 is 3. 10 is 2. 11 is 4. 12 is 3. 13 is 3. 14 is 4. 15 is 3. 16 is 2. 17 is 3. 18 is 2. 19 is 4. And 20 is 4. All right. Any of those that you'd like to go over? Jace. All right. Let's look at 15 and 16. Number 15 is showing you a junction in a circuit. And I want to know, what is the reading of ammeter A? What happens at junctions, whether it be in a circuit or on a highway, is that whatever goes in has to come out. So let's look at what's going on here. Right now, I see 2 arrows going into that point. That's 6 amps and 2 amps. At the present time, I only see 5 amps coming out. This equality has to work. Right now, it doesn't, because I have 8 equals 5. I need to make that work, which means that this current is also coming out of the point. I'm going to add it to the outside of the equation, which means that that current is going to be 3 amps to make that equality work. Whatever goes in must come out. Okay, number 16 is the same thing. Let me just make these arrows a little bigger so you can see the direction of these a little clearer. I know those arrows were really tiny. I apologize for that. We're looking for whatever goes in to equal whatever comes out. So in this diagram number 1, I only see 2 amps going in, but I see 8 amps coming out. That does not work. So 1 is not correct. In number 2, I see 2 and 3 amps going in. That is 5 amps. And I see 5 amps coming out. So 2 is the correct choice. If I look at number 3, I see all 3 of these going in. So that is a total of 10 amps going in and nothing coming out. That can't be. In number 4, I see 2 amps and 5 amps going in. That's 7 amps and 3 amps coming out. That cannot be. The only one where the equality works is choice 2, where the 2 amp arrow is going into the point and the 3 amp arrow is going into the point, and the 5 amp arrow is coming out of the point. Okay? And that's why it's choice 2. Anything else? Anything else you want to ask before we take a quiz? How are you thinking? Number 4. Okay. What is the magnitude of the current in ammeter A1? Okay, A1 is only going through the first resistor. So what I'm looking for is I1. In a parallel circuit, I know voltages because they're the same as the battery, and that is 12 volts. And I know the resistance is 10 ohms. I'm going to use Ohm's law applied to that resistor, that branch. R1 is V1 over I1. So I1 is V1 over R1. I'm going to plug in 12 volts over 10 ohms. That is 1.2 amps of current, choice number 3. Anything else you'd like to ask? Gabby?
11.
Number 11. Number 11 says, that's this one here, what is the current measured by ammeter A? Ammeter A is measuring the total current, which means in order to get it, I need the total resistance and the total voltage. I know the total voltage, but I don't know the total resistance. I have to get that first. And the way we do that is by using 1 over Req is 1 over R1 plus 1 over R2 plus 1 over R3. So if I work that out with 20, 30, and 60 ohms, so I'm going to do that real quick, I get an equivalent resistance of, I think it's 10. Yep, it's 10 ohms. So the Req is 10 ohms. Now I can get the current using Ohm's law, where Req is V over I, so I is V over Req. That would be 110 over 10. So that gives me 11 amps, choice 4. Anything else you'd like to ask? Jace? Number 9. Ask for the current reading of ammeter A. Again, ammeter A is not in the branches, which means that is measuring the total current. To get the total current, I need the total resistance and I need the voltage. The voltage is 24 volts. The equivalent resistance is going to be found by using 1 over Req is 1 over R1 plus 1 over R2. So if I do that with those two resistances, I get an Req of 3 ohms. Now I can use Ohm's law. Req is V over I, so I is V over Req. That is 24 volts over 3 ohms, which is 8 amps, choice number 3. Anything else? No? All right, so then what we're going to do is take your quiz now. You can use your homework. You will need your reference table and your calculator to do these 3 questions. I would suggest you do this in pencil because there is a diagram that I asked you to draw using proper symbols from your reference table. Good luck. When it's done, just turn it over so nobody can see your answers, please. Who still needs more time? Okay, I'll give you another minute. All right. Please make sure your name is on top of that quiz and pass it down this way. Then I'd like you to clear your desk of everything but your reference table and a pencil. You're going to put everything away because you're not going to be at your seat for the rest of the class. You're going to be up and moving around. Put everything away except your reference table and a pencil. No calculators necessary, just your reference table and a pencil. Definitely want to have a pencil for this, because if you mess something up, you want to be able to erase it and fix it. You may not know that you messed things up until the end of the lab, in which case you'll have to go back and redo some things. 29 is because I'm up the screen. All right, ladies and gentlemen, on the top of the lab packet, let's go ahead and put your name where it asks for it, please. Go ahead and put your name where it asks for it, please. This is lab 29. You will be doing this in a group. I'm going to ask you to tell me who you're doing this lab with. In the lab, what you're going to be doing is circulating to 6 different stations. You can see they're around the outside perimeter of the room. Station 1, station 2, 3, 4, 5, and 6 in the back corner. Okay, and you're going to go from one to the next. I'll tell you when to move on to the next station. You're not all starting at station 1. You're going to start at one of 6 stations. Each station corresponds to one of 6 different circuit diagrams in this packet. 2 of the circuits that have been constructed for you are simple circuits. 2 of them are series circuits. And 2 of them are parallel circuits. You're trying to figure out which circuit you're looking at. Now let's go over some things that you're going to use as a group to help you figure out which circuit you're looking at, okay? They don't have batteries. They have those variable voltage power supplies that we used in the Ohm's Law lab. You are not touching anything at any of the stations. Please don't touch, because these are very finicky. So what I would suggest you do, and I'm going to put this on the back, is first determine the number of bulbs. Looking at the number of bulbs will help you figure out, is this simple, series, or parallel? Right? Because the simple circuit's only going to have 1. If there are 2, it's either series or parallel. Then count the number of meters. Some circuits have 2 meters, some have 3, some have 4. Look at your pictures. Try to see if you can match those up. Then, the type of meter will indicate what it is. So, if it is turned to 20 in the DCV, that means it is a voltmeter. If the dial is turned to 10A, that means it is an ammeter. All the circuits, each circuit is either all voltmeters or all ammeters. And then lastly, follow the wires. So if you follow the wires and try to compare it to the diagram, that should lead you to which type of circuit it is. Okay? You'll have to figure out which is which. Now, once you have figured out which diagram it is you're looking at, okay, I am looking at circuit diagram in question 3. Let's say that's what you figured out. The circuit in front of me is this one. What you then have to do is figure out which meter is reading which value and record the value of the corresponding meter on the picture. You see, it gives you a place to record the values. Just write the numbers down from the meter that you see. Then what you will do after that, every single one is asking you then to write a mathematical statement. That means an equation which relates those 2 values to each other. Or write an equation that relates these 3 values to each other. Or write an equation which relates these values to each other. Now this is I1. I know it's a little difficult to read. That's 2, 3, and that is 4. When you write the equation, the symbols that you put in the equation may only refer to I1, I2, I3, and I4. You're not putting any numbers other than the subscripts, and you will not use the exact symbols from your reference table. You have to write the equation for the symbols on the diagrams. So you have to kind of customize what you see on your diagrams, or customize what you see on your reference table to help you write what's on the for the diagram. Make it specific to the diagram in front of you. You understand what I'm saying? Okay. The other thing, these are real circuits. Everything we have done this year is for an theoretical circuit, which assumes that wires don't have any resistance. Real world, every wire has some resistance, and we learned about how to find the resistance of a wire using R equals rho L over A. What that means is that the values you see on the meter may not match up to the theoretical equations we have on our reference table, but they should be close. You understand what I'm saying? So, for example, when I look at this equation on my reference table, V equals V1 plus V2 plus V3. V always represents the voltage from our power supply. V1, V2, and V3 would be the meters. This may not add up perfect with the numbers that you see in front of you at the station. But if it's close, it's good. Okay? Likewise, this says things should be perfectly equal. They may not be perfectly equal, but they should be close. Okay? So you have to kind of, I'm telling you to take your reference table around with you because that may also guide your thinking when you look at the numbers. Oh, it's got to be this because I see things match up or they don't. You follow what I'm saying? You're going to do this as a group. So first thing I'm going to do is put you in a group at a station. First thing you're going to do when you get to that station is write your partner's names down on the partner's line on the front of that worksheet. Then I'll give you a couple minutes to work at that station, and then I'm going to tell you to move. Whether you're done or not, you are moving because another group is coming up right behind you and needs that station. You may not move ahead until I tell you to. Okay? Do not move ahead. If you keep moving at the pace I'm telling you to, at the end, you will have an opportunity to go back to stations where you go, oh, wait a second. I thought I was looking at this, but no. And now that I've seen all of them, I realize I messed up. I need to go back and switch things up. And then you have the opportunity to do that at the end, once you've seen all 6. Okay? And I'm going to collect this from you before you leave. Good? Okay, let me put you in groups. We're going to have 6 groups. So I'm going to have the 3 of you gentlemen start over at station 2. You can get up and go. Have the 3 of you go over to station 3. Get up and go. 1, 2, 3. The 3 of you are going to head to station 4 in the back. 1, 2, 3. Let's go to station 5 in the back. Gabby, Alex, and Cora go over to station 6 in the back corner. And Tran, Logan, and Jerry, come on up. You can start at station 1. Again, don't touch anything. If a light bulb goes out, let me know. Something's wrong. And if a meter is giving you a really weird number, like a 1 on the far left, call me over. That's something wrong too.